So welcome to the Altair SimLab tutorial, which is the assembly with the shared nodes. Let's see the problem description of this model. We will see how to align the cylindrical surfaces, create the shared cylindrical or planar faces, check for the shared entities, separate the shared entities to obtain the coincident nodes, and clean up the joint parts through remeshing. So let's see the option Align Cylindrical Surface. So the first step is to retrieve the SimLab database. Go to File, Import, Database, select the location, and select the SLB file and say Open. Now the second step is to align the cylindrical surfaces. Isolate only the rod body first. Now go to Geometry, Features, select the option as Align. In the Align option, select the cylindrical option. Now select the cylindrical face of the rod. Show the pin body and define the cylindrical face. Select the cylindrical face of the pin. Click OK and say Apply. So you see here both the bodies have been aligned. So next, let's see how to create the shared or cylindrical or planar faces. So the steps 3 is to join the shared cylindrical faces. So isolate the pin rod and the piston bodies. Go to Geometry, Connect, select the option called Join. Now use the option which is the partial cylinder or partial cone option and select the two bodies. And click on Show. You can see that three faces of pair have been found and say Join. So redisplay the bodies once again. So the next step is to see how to join the shared planar faces. Again, go to Geometry, Connect, select the option called Join. Now use the option this time as the planar faces. Select the rod and the cap bodies. Select the preserve mesh bodies. Say Show. You see that two faces of pair has been found and click on Join. So this is how you can use the Join option to create the shared planar faces and the cylindrical faces. So now let's see how to check for the shared entities. The step 5 is reviewing the shared faces. Go to Geometry, go to Connect and select the Shared option. Select all the bodies and say OK. So you can see that total of number of shared faces are 14 here. Redisplay all the bodies. Now we will see how to apply a local mesh control. So isolate only the pin body. Select the outer cylindrical faces as shown here and go to the mesh control browser. Duplicate the mesh control isoline mesh control plane faces. Double click on that and enter the parameters as shown here. And click OK. Redisplay the model once again. Now go back to the assembly browser and now we will see how to remesh the shared faces. Go to Mesh, Remesh. Enter the parameters as shown here. Select all the bodies. Make sure you have in the advanced option you have selected the shade faces and click OK. So you can see here that the shared faces has been remeshed. Redisplay the model. So the next step is to separate the shared entities to obtain the coincident nodes. So let's see how to do that. So the eighth step is to create the coincident mesh. Go to Geometry, Connect, select the shared option, select all the bodies and say OK. So total number of shared faces are 5. Then click on Separate so that all the bodies are being separated. Now go to Connect, Shared Faces, select all the bodies and click OK. Now you see that there are no shared entities found. As we have used the option called Separate, so we don't see any shared faces now. So next, let's see how to clean up the joint parts through remeshing. So the next step is which is the quality check, which is an optional step. Go to Mesh, go to Quality Check, select all the bodies, and make sure you have used the element type as trial because it's a 2D mesh. So we will check the quality parameters for aspect ratio, edge length, interior angle, stretch, and the skew. Enter the parameters as shown here and click on compute. So once you compute, it will give you a detailed elements where the elements are failing and the count of it. So individually, you can do an auto cleanup. So click on cleanup and say auto cleanup. So once again, select all the bodies and say compute. You can see the quality parameters for the edge length and has been created, has cleaned. And now you can do the cleanup for the interior angles. And once again, compute the model. And you can see all the quality parameters have been cleared here. So go to quality, quality check new. Select the quality specification, which is the OptiStruct quality. Okay, here we need only the tria mesh because we don't need any other parameters here. So you can only just select that and compute, select all the bodies and compute the quality parameters. Okay, so here you can see that there are no errors available, which is a zero error check. So this is how you can check the quality parameter for this model. So the next step is to create the volume mesh. Go to mesh, go to tet mesh. Make sure you select the option which is the tet 4. Enter the parameters as shown here. Select all the bodies and say OK. So you can replace the mesh with the existing model and say OK. So this is how you can generate the volume mesh for these given model.